Hi, hello dear students, welcome to Karnataka SSLC online classes. In the last class we have seen about the introduction part of triangles. So I have given some examples and what are called to be similar triangles, similar figures, okay, that we have discussed. So in the today's class we'll learn about the first exercise, okay, it is 6.1. Yes, it is fill in the blanks with the correct word given in brackets. See, first one, all circles are dash. Okay, so here the all circles are either congruent or similar. Which is the correct option? See, we know when we consider circles, okay, do you think all circles have same radius? If I consider circle 1, okay, with radius r1, okay, and circle 2 with radius r2, okay, so we find different circles in the sense the radii are different. Okay, so when radius are different, then I can say the size is going to be different. So one is smaller circle, you can say this is smaller as compared to the other one, so the other one is larger as compared to the first one. Okay, so here you can see the shape is same, the shape of these two figures is circle, but whereas the radii, okay, here r1 and r2 they are different, so I can say they are similar, not congruent, isn't it? So you need to remember the similarity of two figures. When can you say two figures are similar? If they have a same shape and they may or may not have the same size. Okay, so this is going to be similar. Okay, the first one is going to be similar. It is similar. Okay, fine. Second one, all squares are dash. Okay, so squares means we have different squares. Okay, if I consider this as a square of side A, okay, I can find one more square, okay, of each side 2A, okay. See, you can see these two squares have the same angles. Okay, the corresponding angles are same, okay, but whereas the sides ratio are different. Suppose if you take a ratio of a by 2a, it is 1 by 2. Okay, so a by 2a is going to be 1 by 2. Okay, so the figures which have a same angles but different corresponding sides ratio, then it is not going to be called to be congruent, but it is a similar figure. Okay, so all squares are again said to be similar. Okay, because we have only shape wise same, but size wise it is a different. So it is a similar. Okay, so we have same shape and corresponding angles are equal and the corresponding sides ratio is also equal, so they are called to be similar. Okay, third one, all dash triangles are similar. Okay, so they have given isosceles and equilateral. What do you mean by isosceles? So isosceles triangles are the triangles, okay, they are the triangles in which any two sides are equal. Okay, third one, so all dash triangles are similar. Okay, so they are given options like isosceles and equilateral. Now if you consider isosceles triangle, so any two sides are equal. Okay, let me take triangle, okay, say for example ABC. Okay, in this AB equal to AC. Okay, and let me take one more triangle, okay, say PQR. Okay, so here again PQ is equal to PR. Okay, see, if you take the ratio of AB by PQ and AC by PR, okay, so the ratio can be different. Okay, because there is no proof that the corresponding sides ratio is the same, isn't it? But if I consider equilateral triangle, because we know for any size of equilateral triangle each angle is going to be 60. Okay, so here it is 60. Okay, 60. Okay, 60. Okay, and again it is 60, 60 and 60. Okay, so for an equilateral triangle the corresponding angles are equal and also the corresponding sides ratio is going to be same. Okay, so all equilateral triangles, okay, so all equilateral triangles are said to be similar, not the with the isosceles. Fourth one, two polygons of the same number of sides are similar, okay, if their corresponding sides, if corresponding angles are what, and their corresponding sides are, okay, yes, think about this. So two polygons are said to be similar, okay, if the corresponding angles are said to be equal. So how that we'll see here, okay. See, so they are saying two polygons. Let me take two polygons as pentagon, okay. So I'll take a regular pentagon, okay, I'll take a regular pentagon. So some property of a regular pentagon is going to be pi 40 by using n minus 2 into 180, okay, and each angle is going to be equal as it is regular, as it is a regular figure. So 540 by 5 is going to be 108 degree, okay. So each angle is going to be here 108 degree, okay, 108 degree. And if I consider one more, okay, if I consider one more pentagon, okay, and again the each corresponding angle is again going to be 108 degree, 108 degree, okay. But if I take the ratio of their corresponding sides, okay, suppose if it is A, okay, it is A, okay, and this is going to be suppose 2A, because regular means all sides are equal, 2A. Now if I take ratio of these two figures, corresponding sides, so it is going to be A by 2A, nothing but you are going to get a 1 by 2, okay. So here the definition of similar figures is going to be satisfied with the first pointer, as each corresponding angles are equal and corresponding sides ratio is also same in the sense here it is proportion, okay. So the what is the first part you can write? The first part you can write is, okay, they are the corresponding angles are equal, okay, and their corresponding sides are proportion or in ratio or in a proportion, okay. This is going to be the fill in the blanks, okay, fine. Next, second question. Yes. So give two different examples of okay, pair of similar figures and non-similar figures. You need to give two different examples. So for the first similar figures, I'll give first example, okay. So first example, so I'll consider two triangles, okay, two triangles of what kind? Two equilateral triangle. I'll consider two equilateral triangles, okay, with 1 centimeter and 2 centimeter, okay. Sides will take it as a one triangle with 1 centimeter, other triangle with the 2 centimeter, okay. So it is, this is one equilateral triangle, okay, and this is one more equilateral triangle, okay. So as each side, I mean each angle in equilateral triangle is 60, okay. In the other triangle, in other equilateral triangle is also going to be 60, okay. But the first triangle has a side value 1 centimeter and other has a side 2 centimeter, okay. So they have the same shape but different size, but if you take the corresponding sides ratio, it is like 1 by 2, 1 by 2 and 1 by 2, okay. So they are going to be called to be similar figures with respect to triangles. And one more example, shall I give square, okay. So the second example I'll write here, okay. So I'll take two squares, okay, two squares, okay, with sides, okay, 2 centimeter and 3 centimeter, okay. So I'll take one square, all sides are equal, okay. So each side is 2 centimeter, and I'll take one more square, okay, with each side you can take 3 centimeter, okay. Again they are of same shape, because both are square. Okay, and the corresponding angles are equal. Each angle is 90. Each angle is going to be 90. Okay, and if you take the ratio of corresponding sides, nothing but 2 by 3. For each corresponding sides, the ratio is going to be 2 by 3, and hence they are similar figures. Okay, now second one. So non-similar figures. For non-similar, you can make use of any different figures. Okay, so first I'll use like two figures, okay, with one triangle, okay, and other you can make use of trapezium. Okay, so triangle I'll make use, okay, and one more is trapezium. So in a trapezium, one pair of opposite side are going to be equal. Okay, so they are obviously different shape, so they are not going to be similar, so they are called to be non-similar figures. One more example. So two figures, okay, with one, okay, with one we will make use of parallelogram, okay, and rhombus, okay. So parallelogram, okay, so in parallelogram opposite sides are equal, okay, and in rhombus, okay, all sides are going to be equal. Okay, so they are the examples for non-similar figures. Getting? Fine. So if you know the basic definition for similar figures, then you can easily identify the types of similar or non-similar figures. Okay, next one. State whether the following quadrilaterals are similar or not. Okay, so when they are asking about the polygons to be similar or not, just go with the two things. One, whether the corresponding angles are equal. If equal, check with the corresponding sides ratio. If both conditions satisfied, then only they are similar. Okay, yes. So for example, if I start with taking the corresponding sides ratio, okay, so from quadrilateral, okay, PQRS, and okay, quadrilateral, okay, ABCD, I'll take ratio. Each side is 1.5 and here each side is 3, isn't it? So I'll take as PQ, okay, PQ by AB, okay, yes, it is 1.5 by 3, okay, so it is 1.5 times 1, 1.52, nothing but 1 by 2. Okay, so if you see for other corresponding sides ratio, like, so I have ended with the Q, means I'll again start with the Q. So QR by here BC. Okay, so it is again 1.5 by 3, nothing but you are going to get 1 by 2. Similarly, you will get, okay, RS by CD is equal to 1 by 2, and again finally you will get SP by DA is also going to be 1 by 2. Yes, corresponding sides ratio is same, but what about the corresponding angles? You can see here angle A, okay, is given, which is 90 degree, okay, 90 degree. Have they given any of the angle here to say A equal to 90 degree, to say other sum of the angles is equal to A angle? Okay, so here no angle is given, isn't it? So I can't say angle P is equal to angle A. I can't say angle P equal to angle A. So here corresponding, and you can't assume any of the angles here. Okay, you can't assume. If they're given, just you need to see whether the corresponding angles are equal or not. Okay, as here angles are not given, you can't write angle A is equal to any one of the angle from PQRS. Okay, so what I can say, the corresponding angles are not equal. When corresponding angles are not equal, so in the two properties, in the two conditions, first property is satisfied but second is not satisfied. So if any one condition is not satisfied, I can say the two given figures, okay, quadrilaterals. Okay, therefore the given, okay, quadrilaterals, okay, are not similar. Okay, you can write it with a proper sentence. I wrote in brief. Okay, so when any of the one condition of a similar figures is not satisfied, then I can say the given two figures are not similar. Okay, so this is how you need to check with the corresponding angles and corresponding sides ratio, which is called a proportion. If both the conditions satisfied, then such figures are called to be similar. Okay, fine. So we have completed exercise first, okay, 6.1. In the next video we will discuss about the Thales theorem, or it is also called a basic proportionality theorem, okay, which is the basic thing you need to learn in this chapter. And there is a more chances that you may get the proof thing. Okay, you need to get the proof for this basic proportionality theorem. So exam point of view, it is very important. So for that we can watch the next video. So in the next video I'll go with the in detail with the how to prove basic proportionality theorem with some activity. Okay, so from the activity you will easily come to know the idea of basic proportionality theorem, okay, which is done by a Greek mathematician called Thales. Okay, fine. So keep watching, keep supporting, and keep sharing. Thank you.